Alright, we came outside and we assembled the pair of shafts off of the cat boat that we're working on with the rudders, and this is the other half of the project here. It's been so long since we've actually pulled these off last summer, the end of last summer. Kind of cut his boating a little bit short when he had the mishap with the rudder. Anyhow, I die-checked the prop ends down at the marina, and he was wondering about checking for run out, and this I told him basically, you want a full check on it, pull them out, bring them over to the shop, we'll put them on rollers, I'll do a die check and so on. Anyhow, I find a crack on this this coupling end of this shaft on the port side, and anyhow, we're getting ready to start on the new shafts. We're going to make two. We're going to keep that one somewhere for his spare. And I got the bores all kind of cleaned up and was checking them with my bore gauge, and I had a little discrepancy of not really feeling quite right on a couple of the items. So we're going to be taking the shaft and we're going to set it up in the lathe, and we're going to dial the tapers in and compare them to our standard 3/4 inch per foot taper and find out what the discrepancy is and actually how much it is, and etc. The material that we're using is Aquamet 22, and these are metric shafts. These are 40 millimeter shafts. We actually had to pay extra for these two shafts to have 1 3/4 inches put back through the mill at Western Branch and ground down from 1 3/4 inches down to 40 millimeter, which is 1 inch 570 blah blah blah. So we're getting ready to head on in and take care of this. We kind of come out here and we kind of put things together so that we had the puzzle, get another look at the puzzle that we opened up last year and refresh our memories, and we're pretty well ready to go. We're going to go on inside and tackle this job. Alright, we got our master taper down here, and we've slid our shaft into here, and we've got it set up against the tailstock so we can run this true. We come over here, we spun this, it was running out about 4, we split the difference just so we were riding in between. It's run out there. That'll give us the truest comparison to our mandrel, which we just put between centers. We haven't even really dialed that in to 3/4 inch per foot, but we're always within the length of that. We're within at least a couple thousandths, and we're just looking, we're not looking for anything out of whack. We're looking for something that shows us that we are as close as, considering the taper to be 3/4 inch per foot, and the needle or the indicator stays pretty close to 0. Now we're going to go ahead and we're going to endo the shaft, and then we're going to check the other two as well. We're going to check all 4 tapers just to verify this scenario and making sure that we're getting a little bit difference on the minor diameter here between the two shafts, which are the difference between two manufacturers. The amount only makes up the difference of about 1/8 of an inch extra draw on one versus the other. It's the only thing that I found so far. But my mandrel does rattle a little bit in a couple of the bores. I don't know if the taper is slightly off on the bore, or there's a high spot or whatever. We'll know more when we get into the lap fits, but I want to verify that we are running the same taper. Alright, so we're going to slide this one out and get the next one in here. Okay, here comes the coupling in here. And I'll kind of show you what we did to judge the other side. Alright, making sure that. Now we bring this down, and we kind of set it up this way so that we can rock it back and forth, and the highest spot lets us pretty well put the indicator straight and level. Alright, now we'll crank it out. It doesn't seem to move, but once we're out here, we roll it over And we see about 3/1000ths run out difference. And we just put it somewhere in the middle there so that we know that it's in the center of the run out, meaning the high, you know, the in between the high and the low. All right, and when we crank this on this taper here, we are holding within 1/1000ths on the length of that taper. All right, now we're going to go ahead and we're going to bring the port shaft in, and we're going to check this one, that one as well. Okay, here's the prop end on the port side, and I'm getting less than 1/1000ths run out there. Now this is where I was at 0. You'll see it go above and below on the high and low because this doesn't have a center hole in it here, so it's going to be a little bit more extreme than the other two, but I just kind of wanted to show you how I was doing this. And this kind of stretches it out about 9 above and 8.5 or so below, and right around the 0, that's about where I was reading my taper, and that's how I was coming up with the medium position to check the taper to match. All right, now we're going to check the coupling in. So far that's 3 for 3 that are matching up to be close enough to 3/4 inch per foot taper. Now here again, I don't know how these people could do all this machining without having center holes in there, unless they're just holding on to the end of their materials or something like that, or cutting them off afterwards. All right, so we got there's center. We're gonna call that center. This one ain't quite as bad. Only got like 10. We can put it in the 5 spot. And there we go. All right, so we're going to consider all the tapers at 3/4 inch per foot. Okay, one of the first things we do is we bring our shaft in through here. We set up our steady rest. We measure back from our edge to where our major diameter, or where the taper usually comes out and meets the outside diameter. We'll hold it there, and we'll put the center drill in here. And so we got 3-jaw chuck, which runs within 1/1000. We've got this running 0, and this was running about 1/1000 right now, I believe. Let's see here. About 1,000 right out here, and this is the rolly end of the material where they start and stop it into the centerless grinder here. All right, now the reason why we do that is because we want to put the center drill here, and when we slide the shaft, we want the shaft to slide through here, and we'll be holding it at 0, and then we want the diameter where we're going to be machining the taper to come out and blend with the outside. We want that to be 0, and we want the end of our shaft to be 0 as well. So, and you can only do this if you start out with a shaft that runs true. Okay, so the first thing we do is we come in here, we want to put a center drill right there. Okay, now we have a center support hole in the end. We can bring out our shaft. Now we're going to go ahead and bring in our taper here, and we're just getting kind of a comfortable position on our mandrel down there. And that's about where we're gonna want to start our taper. And our male end here is gonna be like 2 7/16 long, somewhere in that ballpark there. Now we can go ahead and we can tighten down our chuck. We back off our steady rest. We put our center in, and we give our length in here, but we know all of our working dimensions that we need to have for clearances for the carriage and everything else to work with our support where we want it. All right. Now what we're got to do is we've got to go ahead and we're going to verify that our mandrel is 3/4 inch per foot on the money. All right, we got our indicator up here, and we bring it up and down to verify that we're on center line. Now I'm not going to bother about setting it at 0, except for put the 0 up here maybe. So we'll crank it so we get to 0. That way it's under its own working pressure. Now we're going to set our travel dial on the lathe at 0. And then we're going to advance forward 6 inches, and half of the taper in 6 inches would be 1/875, and that's what how we're gonna adjust. We're gonna adjust it within a 1/2 thousandths for 6 inches. Okay, there's 6 inches right on the money, and we're at 1/875 and about 2/10 or so. Now I like to do this a couple, 3 times to make sure that we are in fact repeating on that same number. Also, this is our very first time coming up here, and we want to verify actually how much running, because we are in a 3 jaw, we're not holding with our steady rest, and we're in the center over here now, and we want to see what our run out is on our shaft. And right now we're running out 4 thousandths, because I'm not holding it with the steady rest here, and I know our 3 jaw has probably got a little bit of a manipulation in it. So what I'm going to do, I'm going to bring it back to half of that, and that's where we're going to judge that, and it just happens to be 875 right now, but we're going to verify that again. Alright, there's 0. Setting 0 there again. Coming up on the 0 right there. All right, and we're at 1/875. So I'm going to go ahead. I want to advance it about a 1/2 thousandths in there. Now that's our travel right there. We can actually tighten this down right here. I'm going to put steady rest on here, and then I'm going to create a true running 0 right there so that you're happy about the shaft being running 0. Within a 1/2 thousandths right there, and you can see that I was able to fluctuate this thing around. There's lap fits, filing, there's a lot of other things that you can come down and get the nitty gritty, of creating your contact that you're going to match between your shaft and your propeller. Alright, back to just calibrating our zero here again. Alright, there's zero. And coming up to our 6-inch mark, which is zero again on our travel valve. And we're at 187 again. Alright, so now I'm going to go ahead and adjust my centers down there until I can pick up that extra half an inch, or half a thousand. Okay, we went a little bit past because we know that it takes a little bit more. We're working only a partial of between center to center. Okay, coming up to zero. Set our zero. And we're coming up to our 6. And we're at 1 inch, 8, 7.5 thousandths. Alright? We're good to go. We're going to pull our regular D&MP out of here, made by Sandvik. Not that we're dissatisfied, but we're going to try a new bit here. This is from made by Seco. And this is a TP200, and we're going to give this a shot. A little bit larger radius, and it's a negative acting insert versus the positive action on the top here. And we're going to see how this performs on the Aquamet material here. We've got a straight thread and diameter, nub diameter here that we're going to turn with this side here, and the other side we're going to turn with our tracer. Because of the different size, oversized taper diameter in relationship to the thread diameter, we're going to do it in 2 different steps. Whereas the standard shafting dimensions that I have on all of my mandrels that shape out from 3/4 up to 2-inch shafts, are all pre-made, and I can do them all with the tracer on the back. But because of this metric size and the size of combination between the taper and the thread, I'm going to do them single. I'm going to single the thread diameter here, and then we're going to trace the taper. Now normally I can take about 50 thousandths per side, and I'm going to put that in. And this is my standard core speed. And here we go. Alright, now it did leave a little bit of a frosty color. Like I said, this is a pretty wide radius on the tip there. We are extended quite a bit out here, and I think our setup is pretty rigid. We'll try another pass. noticed something different here, and I'm leaning forward on here. I'm staring down here, and I think it was because I was facing off some couplings here that I have it tilted that way. And I just want to go ahead and make sure that I might be having benefit of the doubt, and my geometry is a little bit off, because it's looking gloss, but it does have a little bit of a raise, and I think the way the chip is curling back on there and kind of gulling the surface is kind of what I think I'm looking at. All right, so I'm going to start it up again. We're going to take off from, I'm going to touch there, and we'll continue that cut. We'll see if that don't help this out. I think it was my mistake. Here we go. Still the kind of thing. I don't know, maybe the way we're out here, it's less stable or not. We're taking about the same depth, but we're working about twice the radius right there, and it might be just a little bit on the chip load right now. All right, so we're getting down close here. We're going to try a couple 25 cuts, just half of what we've been taking. We'll see how it acts. Okay, I'm going to put my other bit back in. It's hard to say whether it might be just this insert here is not the cup of tea for Aquamet material, and nothing's wrong with the bit. I don't see any edges or anything else bad on it. And let me blow this out. Kind of why I stick with a lot of the things that I stick with, because they work. When you put them in there, you know what you expect as far as length of time and all of that stuff going in there. All right, now we have got about 100 thousandths come off of here. So we always have a little bit of a cleanup cut. Here we go. Okay, nice and smooth, no fuzziness. That came off crisp and clean. All right, right now it should be, well, that's what I wanted. I wanted 1 inch 1/8, and I'm right on that money right now. and I just need to go ahead and I like to have it about 5 under that, just so I have a nice crown on the top of my threads all the time. I don't like to have it bottoming out in the crown of the thread there itself. And but that's one of the proven bits. Normally I use the C&M, but because we're coming in here and I wanted a straight shoulder there, the D&M works a lot better.